Hi, I am Laura and I will be talking about storing bioimage data. In this RDMbite, you will learn what to consider when planning storage for bioimage data and some ideas of how to organize your data. The first thing to consider is that bioimage data can be very large. Individual image files can be several hundreds of gigabytes depending on the number of channels and time points. Also consider the analysis you will be doing. If you need to save processed image files like ground truth segmentations, this has the potential to double the size of the data you need to store. For bioimage data, you will need to store multiple different file formats. If you are using multiple instruments, these may output different proprietary file formats, and you will also need to store metadata and documentation files. If you are analyzing your data, you may need to store the analysis code. Finally, you need to consider how fast the data can be read from where it is stored to your computer's RAM, so that it may be viewed and processed. This can be a real bottleneck for image analysis tasks. This is particularly important if your images are larger than the RAM of your computer and you will be using lazy loading or virtual stacks when working with your data. Once you have worked out the requirements for your data storage, contact your IT department to identify solutions they can offer. Whatever the solution is, remember to make sure your data is properly backed up. Proper backup ensures that at least 2 remote copies are stored to combat corruption. You might want to consider an image-specific data management platform. Have a look at the options on the Bioimaging Data RDM Kit page. One option is Amero, which we will cover in more detail in another RDMbite. For long-term storage after your data has been published, consider sharing it with a public repository. Some examples for bioimage data are listed here. This will make your data available to others, as well as knowing there is a copy stored elsewhere. Options for repositories can be found on the Fair Sharing website. In the following slides, I will provide a couple of ideas for how to structure your directories if you are using standard file storage. The structures are based around the RDMbi guidelines, which you can learn more about by watching the related RDMbites. In the first option, a top-level folder is used for the study, which will contain everything relating to the project. Within the study folder will be the study metadata and then subfolders for each of the study components. Each study component subfolder will contain the related data, results, and analysis scripts, along with a separate metadata file. Another option, starting again with a top-level folder for the study, is to have subfolders for your data, results, and analysis, as well as a documentation folder. You can then have the option to split each of the data, results, and analysis folders for each study component, but keep all the metadata files in one place. Make sure that you have a good naming system, so you know which metadata belongs to what data. In most cases, this can be achieved by using a common ID. Whatever structure you decide to use, don't change it. Once you start cross-referencing files and folders from one another, it can be very difficult to untangle the mess if you try to move things around. Stick with it even if it isn't perfect, and keep in mind what you would do differently for the next project. Please see links to additional resources alongside this video, as well as other RDMbites in this series.